everyone. In this video, we're going to see some looping control statement in the Unix lab. So the first question, we're going to jump it out and we're going to see a shell script which is going to be printed on, which is going to print a Fibonacci series. So just jump on to the code. So this is the number. So how many terms need to be generated? We're going to enter read number and then it's going to print out in order. So we're echoing x and y, which is 0 and 1, and while I is which is 2 less than the number entered by us, which is lesser than it, we're going to just increment the I and it's going to calculate the, what would I say, it would just calculate the x and y. So after calculating x and y, it would just echo z and it's going to just change the x into y and y into z, and it's going to be printing. So we'll just run the how many terms are needed to be generated. We can see 4 terms, so 0 plus 1 1, 1 plus 1 2. So like that, if in case we're going to show 9 terms, so it's going to print out 9 terms. So this is how it's going to be executed. So the second file is how to find a sum of following series, like 1 square plus 3 square plus 5 square, like that. So we are going to enter the number. We are going to initialize a variable sum, which is going to be given as value 0. So there we're going to use a for loop where the I would be equal to 1 and I should be lesser than num, and I should be incremented each turn. So there we're going to make a term square, which is going to be using I into I, and it's going to save that square value into sum, and it's going to increment, and it's going to keep on and on until it's the I matches with the number entered by us. So that's going to give us the required number. So we're going to enter what is going to be the value. So we can say it. So 1 square plus 3 square plus 5 square plus 7 square, so that is the value. So 1 square is 1, 3 square is 9, so 1 plus 9 10, and 5 square is 25, 25 plus 10 35, and 35 is there, and 7 square is 49, 49 plus 35 is 84. So this is how it's working out. So the next one is how to get whether the number is Armstrong or not. Armstrong is just each digit of number. If we cube it and add it, it should give the same number in return. So we have used it here. So while n is greater than 0, we are going to just use modulus of that particular number, modulus of 10, and we are going to cube it and save it, and we are going to divide that number into 10 and use it in the next iteration. And at the end of the iterations, we're just going to check the new term and the already entered number by us, whether it's same or not. If it's same, it's going to be give Armstrong number, or it not be an Armstrong number. So we can check, like, we know 143 is an Armstrong number, so we're going to enter 143. So 153 is an Armstrong number. So we can see 143 is not an Armstrong number, but in case if we give 153, so it's giving 153 is an Armstrong number. So that's how it's going to work. So we're going to jump on to the next one. So this is checking whether the string is palindrome or not. So here we are going to enter the string and we are going to find the length of the string. We are going to keep an empty string p. So while c is lesser than the length, if the count is lesser than the length of the string, we are going to carry on an iteration where we're going to use a substring of each digit and place it into a particular string, and we're going to increment the count until it is lesser, it crosses the length of the particular string. So if that particular string and the entered string by us is matching, then it would be a palindrome, otherwise it would be showing as non-palindrome. So we're going to just run the program here. So we can say enter the string. So this is a palindrome, so it will show us a palindrome. In case we are going to give something like this, it will show it's not a palindrome. So this is how it's going to work, and we're going to jump on to the next one. So the next one is to find out the prime number between two what would I say, two numbers. So we are going to enter the two numbers, start, end, and we are going to use it in a for loop. If I is equal to start and I is still end, it's going to increment, and we are going to make a p as 0. P is actually basically a flag. Using another for loop, we are going to use j equal to 2, and j should be lesser than I minus 1, and it's going to be j going to be incremented. We know that a prime number is only divisible only by that number itself and 1, so we are going to eliminate those two things, and we are going to divide it each in each iteration. In case the modulus of that number is equal to 0, we are going to break it out and we'll just say that it is not a prime number. In case it's not divisible, it would show that p equal to 0. If p equal to 0, it would just show that it is a prime. So we'll just enter the starting and the ending, and it was showing all the prime numbers present in between those two numbers. And this is the program. We're going to jump on to the next one, which is basically based on to sort elements in an array. So we have basically done an array where the for loop we can see I equal to 0, I equal to num I plus plus, and for I equal to is equal to the number of I, and j equal to number of I, and j is lesser than num. We're going to do, and we're going to make an arrays. If the array is lesser than this one, then it's going to forward it to this, and the number would be in, what would I say, the numbers would be entered here, and the numbers in the array are there. Then it would just print out the numbers, so it would just check the forward and the next element and whether it is lesser or not. If it's, then it will to change its position, and yeah, that's how it's going to be done. So we're going to enter the number of digits 4. We are going to enter 4 7 2 1. So we can see number in ascending order, number in descending order. This is basically a banking one, so we'll just show how it's working here. So basically we're going to enter the password is Linux, so we're going to enter a wrong password like this. So it's showing wrong password one time. Maybe you want to continue, yes. I'm going to enter the right password here now. So if I press the right password, it's showing login. So now I'll again give a wrong password here, so it's showing wrong password 2 times. You want to continue, yes. If your choice 3 times, then enter choice, enter password. It should 3 incorrect attempts blocked. So do you want to continue? I would say no, so it would come out of it. So the next program is, the last one is a banking one, where ATM. So we are going to choice for everything here, withdrawing money, checking the money and all. So enter one for deposit, so we are going to enter the amount of money, so money is deposited. So we are going to continue it, and we're going to see balance inquiry. We can see the balance. It was previously we have placed 1,000 rupees, so 1,000 plus this is there. We're going to take out money. We'll just take it out like we're going to deposit once more. And would I deposit once more? No, I think let's deposit once more, and we're going to just check the balance. Okay, this is the balance. Now we're going to withdraw a possible amount of money. So we're going to withdraw 367. Okay, 367, we're going to withdraw it. So 367 is withdrawn, and we're going to just check the balance is 990. Now I'm going to withdraw 1,000, which is actually not possible, but it would throw an error hence. So this would, so it would share not enough money. So that's how it's going to work. So that's basically the experiments involving in the looping control statement. So thank you for watching.